packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Scott Hogue. On the show, we discuss all things IPv6, strategy, design, deployment, and operations.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We run a consulting firm where we get IPv6 working for our customers.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're going to talk about DHCP and DHCPv6. Scott recently published a blog post over at the Infoblox IPv6 Center of Excellence, and we think the audience should check it out. And we wanted to use this opportunity to sort of talk through some of the operational differences you might encounter with DHCP that might crop up. So let's dive into it, you guys. Let's talk about what might be some first things on our list that we think folks should really be paying attention to in terms of DHCP versus DHCPv6.
Yeah, I wrote this article because many people, as they're starting to learn about IPv6, they compare and contrast it to what they know and what they're familiar with. And for all enterprises, they use DHCP. And when they're embarking upon an IPv6 project, they think, oh, well, maybe we'll use DHCPv6. And how is it different, or what are the considerations as we plan our deployment? What are the little nuances, differences between DHCP for IPv4 and DHCPv6 that we need to be aware of? How does it affect, how we manage a network or configure a network? And so that was kind of what I wanted to write about, what I wrote about.
I guess the first operational consideration is, should you even use DHCPv6, right?
You don't really have choices in IPv4, right? I mean, if you want auto addressing, basically it's DHCP or nothing. And v6, though, you've got SLAAC as an alternative. So thus your question, you do have some operational choice.
Yeah, I guess most people don't really think about that because you don't know about it coming from the IPv4 world, right? SLAAC's not a thing. So you just assume that you're going to be doing DHCPv6 and you just sort of move ahead operationally thinking that's going to be a match one for one. In most cases, I think that's probably an accurate statement. For many organizations, they probably want that sort of granular control, and it's operationally something they're used to. So I would argue it makes a lot of sense to continue using DHCP and then moving over to DHCPv6 for IPv6. But there might be some corner cases where it doesn't make sense. I don't know if we want to dive into this show necessarily talking about what those would be. And we covered a few of those in some previous shows, but just realize there are some OSs that might struggle with DHCPv6. And so you might run into some corner cases where you're going to have difficulty operationally. Not yet.
Yeah, there's legacy devices that don't support DHCPv6, and you need to accommodate them. And the only option they may have is stateless address auto configuration. And so that's the option there. With the DHCPv6 or DHCP, you really would want to use DHCPv6 if you're familiar with DHCP. You have that infrastructure already. You have DHCP servers, you have DHCP relays, you've got clients that are DHCPv6 capable or DHCP capable, and you probably have processes around maybe logging addresses that are assigned to nodes in a database or in a security information event management system or something like that, and having some security requirements around logging addresses and who gets addresses in your environment. And you need that security compliance logging function. Maybe you also have a method of doing static reservations. You have a certain address, you want it bound with a fixed address to a MAC address, and you want to do the same thing with DHCPv6, you can do the same thing, but you couldn't do that with SLAAC. Maybe you have dynamic DNS and you like having nodes register their addresses with their name in a forward lookup zone and complementary, reverse mapping zones. And you want to do the same thing in DHCPv6. So SLAAC wouldn't have that functionality of doing dynamic DNS. So those are considerations why you would want to use DHCPv6.
Yeah, and I think there's some operational considerations around the tooling too, right? So you might have chosen a particular platform. As an example, we'll just use Infoblox because they're pretty well known in the DDI space. And if you're making use of the DDI platform to be able to run, administer, and use the API to be able to use automation to configure addresses and things of that nature, it's far easier to stay on that platform, use DHCPv6 as part of the suite or family of what's already provided there. It already has that set of capabilities. And so it just naturally, operationally makes sense to continue extending what you're doing versus if you're using SLAAC, you're definitely going to run into differences in terms of how your workflow would handle certain situations of understanding what addresses are available. Like you completely have to change how your automation would work, right? in terms of provisioning addresses and what goes on.
I don't know if we have anything that really accomplishes what DDI platforms accomplish in terms of that basic accounting of what is connected to the network and the identity of those devices with SLAAC. I mean, obviously, if you've got a pretty elaborate, like say DevOps component to your organization that could go in and code all of the sort of back-end steps required to say log into routing devices, anything that's got a router advertisement going on that's offering SLAAC as an addressing function, and scraping neighbor discovery caches to learn what's connected and the information related to that. That's all something that doesn't really have a commercial off-the-shelf solution, I guess, which, I think with the DDI platforms, you kind of get that. And not only does it match your existing operational model of using DHCP, but, it doesn't seem like there's really a way to get there from here with SLAAC, just in terms of that functionality and that off-the-shelf sort of ease.
Yeah. Security operators need that situational awareness of knowing who's in the network. And maybe today an enterprise is using a DHCP system that's integrated with their vulnerability scanning system. When a new lease is given to an end node, that address and an API communicates to the vulnerability scanning system, telling it, hey, I've given out a new address. Maybe go ahead and scan this the next time you're doing a scan. And you could do the same thing in DHCPv6. If your DHCPv6 server is integrated, probably has the same API functionality, because your vulnerability scanning system won't do wholesale, like scan all the v6 networks. It won't do that. So the vulnerability scanning system, the network-based scanner, has to be told what addresses are allocated or assigned to nodes. And a DHCPv6 server can do that, and probably has that same functionality if you're doing it today for v4. With SLAAC, there's no method in the router because it is stateless. The router isn't keeping any state about who has what addresses and what addresses have chosen. In SLAAC, the choice of the address is up to the end node, and the end node doesn't have any responsibility to log that to a vulnerability scanning system or anything like that. So there's no functionality there. So if you're using DHCP integrated with a vulnerability scanning system, you may want to have that same functionality with DHCPv6, and you can't do that with SLAAC.
Those are all excellent points. And I think for the listeners, it's really all about, do you have the time and energy to go effectively build this yourself? Which is really what Tom's point was. You can absolutely glean all the information that would be required to do this. Across very large networks, I would actually say this would be pretty difficult to do at scale easily to understand what's going on. But, in smaller networks, it's definitely doable. There's a core set of, philosophical differences about how SLAAC and DHCP sort of operate and what operational mode you're in. So I would think there's use cases where SLAAC makes sense, where maybe there are dynamic devices that are popping up and down off the network, and you don't care about them because of how they're built or the certificate types they have or the services they provide. Don't require the sort of tracking or logging or even, maybe accountability in the same way that maybe end user devices do, or, tablet devices or medical devices or other things that might be, important to understand where they are from an asset basis on the network, which gets to your point, which is how do you figure out how to scan, detect, and figure out what's going on for those particular devices that you do want to have those sorts of controls around. And maybe a good example is talking around guestnet services. Do you really care? You may care in some environments whether the guestnets are doing particular things and what addresses they're using. In others, you might not, right? If you're at a coffee shop, it may just not matter, right? Just let the thing get an address and go. But maybe in a more secure network where, yes, you're going to provide guest access, but you need to have some sort of logging or accountability about what that device is. You might want to use DHCPv6 at that point, and you might only want it to have one address. Maybe that's a good point to talk through too. Just operationally limiting how many addresses a particular end host gets, right? Because with SLAAC, the host gets to make that determination, not the network itself, right? So there's no controls over that. Versus with DHCPv6, you can assign a singular address within that prefix to that device, and that's the one it uses for everything, which gives you a lot more granular control, right? You can use that information to write dynamic access lists if you want to control what traffic is coming in and outbound if that's important or something you need to do. If hosts are just making up addresses randomly, it's very hard to determine whether you should be allowing or permitting that given traffic or not, right, in the network. So I think those are all good operational issues that are going to come up. I don't know if there's any other top of mind operational issues that we think. I think that's probably the major one is, should you use DHCPv6 or SLAAC or not, right? Sort of debate.
You mentioned the possibility of using SLAAC and operationally for, say, like guest networks. And of course, something that we've mentioned multiple times on the show in the past is the lack of support for DHCPv6 in Android devices. It's certainly a factor in you deciding, it's like you've got a couple of different choices for auto addressing. We're talking through what DHCPv6 offers, how it compares and contrasts to SLAAC. Listeners probably getting the sense that in terms of standard enterprise operational models for IT, that DHCPv6 is really a continuation of the operational model that you have with DHCP. But in a scenario where you absolutely wanted your devices on your guest network to use IPv6, you'd really be stuck having to run SLAAC in order to support the Android devices that would be connecting to the network, unless you wanted to just dual stack and have them connect over IPv4.
Another one in the security realm is, imagine you kept track of MAC addresses of end nodes. Or let's say you're a university network and every fall students come in and enroll, and the campus IT department captures information about new students' devices that are going to be joining the campus wireless network, whether it's in a residence hall, the stadium, or classroom, and they capture the MAC address of that device. And then they know, well, that MAC address is assigned to this student with this student ID, and we allow that on the network. But with DHCPv6, it uses a DHCP unique identifier, a DUID, which can be as simple as the link layer address of the device, the MAC address, or it could be more complicated, hexadecimal number of varying lengths depending on the host OS. And so it could be a more complicated process to then get the students DUID for their wired and wireless interface and then add that to a database of students. So operationally in the past, you've just recorded MAC addresses of wired and wireless interfaces on student mobile devices. Now you're capturing a MAC address and a DUID from that device.
And you might be capturing an interface identifier too, right? Depending on whether multiple interfaces are in use. So it definitely operationally gets a little bit more complex in those environments. I would think you would want to rely on other credentials maybe.
Yeah.
In those environments, I would probably argue at that point, let's switch to some other identity access management platform to authenticate who and what you're up to. And that information just becomes an additional piece of metadata to help them determine how trustworthy you and your device actually are.
Yeah. Students are smart. They know how to print out a test page from a printer and configure their laptop with the MAC address of the printer. They're smart. That method I just described, like MAC auth bypass type technique, that's like a screen door. Little tiny bugs can still get through or around the edges of the screen door.
And the dog can just bust right through that. So
yeah.
It's not a real door.
No.
But yeah, I think there's maybe some other operational things that fall in the realm of doesn't exist in IPv4, but does exist in IPv6.
Or vice versa with high availability and DHCP failover. And, if we're advocating, which I think we are and have been for quite a while, to say, if your operational model is DHCP, well, you're going to use DHCPv6 in your environment. And everything that you know and love about DHCP will work in DHCPv6. But, when you check under the hood, as we're talking about the difference, say, between MAC addresses and DUIDs to track clients, that's one difference. Another one is the fact that there's sort of trivial, I don't know if I would call it trivial, but basically a checkbox to get failover redundancy for DHCP, but we don't really have the same thing in DHCPv6. And we sort of have to use some other techniques to ensure that high availability, which is maybe not as much of an easy button as folks are used to with DHCP.
Yeah, I think that's a vendor catch-up thing, maybe, just in terms of just more v6 deployments coming in there and people realizing that they need that as a feature set to get parity, maybe.
Yeah, maybe so, except that, we've had the DHCP v6 failover, RFC for, a decade now. I'm not sure. It's been quite a while. And I guess, there are counter arguments that it's operationally really not as big of a deal as it could be made out to be. If you're sort of new to administering DHCP v6, and doing things like splitting up a pool in order to make sure that there's addressing available, sort of a workaround. There's even an RFC that talks through all the workarounds related to initially the lack of DHCPv6 failover functionality. So operationally, it's not as if you have no choices there, but I don't know if it is, sort of something that you don't have to think about at all in DHCP, and maybe you have to give it a little more consideration with DHCPv6.
Right. Certainly not worried about collisions or building split scopes or anything else like that.
Thanks for being a Packet Pushers listener. Did you know we've got other IT-related shows you might want to check out, like Heavy Wireless? Heavy Wireless is a deep dive into Wi-Fi, IoT, wireless security, and more. It's hosted by Keith Parsons. He brings decades of experience to conversations with wireless engineers, industry experts, and vendors. So whether you're a WLAN specialist already or looking to expand your skill sets, Heavy Wireless gives you the technical know-how and industry insights to succeed. Find it at packetpushers.net or wherever you get your podcasts.
You might also consider, your DHCP lease times. For IPv4, you may have your lease times set quite low because you have a limited pool size or limited number of addresses available in your scope or range. With IPv6, you have this unlimited supply of interface identifiers that could be randomly allocated and assigned to nodes from the /64 range. And so you may have a different lease time for DHCPv6. So you may have some timers that are different because just the abundance of the v6 addresses that you have at your disposal.
Yeah, that's a good point.
So, when you're thinking about split scopes or redundancy or high availability or DHCPv6 failover, with DHCP failover, the synchronization of the database is pretty small. It's maybe a /24 and it maybe only has a couple hundred nodes on it. With DHCPv6, if you're keeping a long lease time and you've got lots of addresses, there's a lot more data that would need to be synchronized for a failover protocol for DHCPv6.
Yeah, and if you have a long enough lease time, maybe it just doesn't matter because your services come back up before the lease timer has any issues and even has to check back in and say, is my address still good? Can I continue using it? Right.
Yeah, you may choose to have really long lease times in DHCPv6, or you may decide to make them the same.
Right. Just operation, whichever makes more sense for you and your org.
Mm-hmm.
I was sort of going in the other direction from what Tom had mentioned, which is probably going more granular, and I was going more expansive in terms of saying features that don't exist in IPv4 that do exist in IPv6. And we don't have to cover it in any detail, but at least to mention DHCPv6 PD, which we've talked about in previous shows, but this whole concept of like a prefix delegation, I don't know if there's really a good analogy in IPv4 in any way in terms of talking about being able to provide addressing downstream to devices based off of a request from a DHCP message type. I guess that's operationally something we haven't really thought about. I don't know if enterprises are really ready to consume that. It was really sort of designed for service providers, but it's becoming, at least in the discussions within the IETF, is becoming of more and more interest for folks to be able to use in sort of dynamic ways within enterprise for provisioning services. So things like if you're using Kubernetes and you want to be able to provide more addresses to a particular service that requests more address space, you can go ahead and dynamically assign it, right? And that has to work in conjunction with routing, obviously, because you can't route an address to someplace and not have a route back to you, right? But that is a new concept overall, and I don't really think that's existed. We've solved that in other ways in the IPv4 realm in the service provider space. We didn't necessarily use DHCP to do that function, right? So I think that's something sort of net new on the table and operationally, maybe more down the rabbit hole than we want to go in this particular show, but at least be aware of the fact that there is a totally different method to assign actual prefixes downstream for other networks to use and potentially set up as a pool for their own DHCP purposes, right?
Yeah. The RFC that we're talking about is unique IPv6 prefix per host. RFC 8273 says you may want to allocate an entire prefix to a server, a node for use inside of itself, possibly for software containers or isolating other processes or tethering or connection sharing or something like that with other downstream devices. And you can do this creatively, and you have the abundance of v6 addresses to do this. You didn't have the ability to do this in IPv4, the scarcity of addresses.
Yeah, we were doing all sorts of crazy overloading and port NAT configurations to sort of accomplish the same thing, or at least to, sort of make it look like a duck and quack like a duck. In this case, we're actually making a duck, so,
Yeah.
So it's a little different.
There's no problem you can't solve with an additional layer of NAT or tunneling.
So true, so true. Was there anything else operationally that we, off the top of the list? I think probably the last one that we highlight just what Scott had mentioned earlier, which was really the logging and security, right? Like There's a whole landscape in there that just doesn't exist for SLAAC, and just operationally understanding the nuances, the differences there is going to be really important to an organization. You want to make sure that you don't leave your security folks out of that conversation, because if they come back to you later and you made the operational considerations of saying, yes, SLAAC just services our needs, it solves our problems, and then they come back and say, how are we going to do X, Y, and Z? You're probably going to have to reevaluate maybe where things are at in terms of what's important and what tools they have available to them. I think I've seen that in more than a few conversations in the past where it's like, oh, maybe we need to reconsider what we're doing there.
Yeah. There's one, the opposite thing, where you can do some stuff with DHCP that you can't do with DHCPv6. And one of those is DHCP option 108. We've talked about this in the past. We did a show on this where we talked about how DHCP option 108 is a v4 DHCP option that can tell a node to turn off its IPv4 protocol for a certain period of time. We don't have that same kind of option number in DHCPv6 to tell a host maybe to turn off its IPv6, or why would you want to do that? But or to tell over DHCPv6 an option to turn off IPv4. So when you're doing these IPv6 mostly networks, you may want to turn off IPv4. You have an option in DHCP to do that, but you don't have an option in DHCPv6 to do that. So there can be some subtle differences there. Like you may have a DHCP option you use today, and the IETF or Internet Assigned Number Authority hasn't gotten around to assigning a similar option in DHCPv6 for you to use.
Maybe that brings up the final operational consideration that we probably should talk through, which is you have the capability to extend DHCP and DHCPv6 versus SLAAC. In other words, that you can provide the capability to provide specific options, and you can even make them specific to your particular environment. If you wanted to write code for yourself for any given reason and assign yourself an option number and not go through IAN or anything else, you can totally do that. It's doable. Probably not recommended, but it's doable. And there's definitely a whole set of standards around building extensible attributes for DHCP and DHCPv6. And operationally, that doesn't exist in SLAAC at all. So that would be one of the other sort of operational considerations. And then finally, the fact that the DHCP option numbers don't necessarily match between v4 and v6, joy, right?
Yeah.
That we don't necessarily match all of them up. So a bunch of them that are maybe more well-known are matched up.
That brings up one sort of corner case operational difference between the two and functional difference. So you do have something called DHCP fingerprinting, which exists in both v4 and v6 because of the option set in DHCP, which I think is more diverse and allows for better identification of hosts by using DHCP options to figure out what the host is in terms of what it's running. I think with IPv6, and I haven't kept up on this, so I could be over my skis here, but I think there's not a similar level of diversity with the DHCPv6 options that would allow you to effectively identify the device, except in a few cases where it's obvious what the device is from that. So that might be one. To the extent that your organization is relying heavily on DHCP fingerprinting, you might see some variance there between what you can do in DHCP and DHCPv6.
Yeah, so you're talking about gleaning information for what the host OS is.
Yeah, determining the host OS by looking at the DHCP option space.
That would probably just improve over time as vendors mess things up. And more options get used, then more and more systems will have different behaviors. So we get to see a bit of that.
Yeah, it's probably falls into the category of you should probably be using some other technique. There's another solution out there for host OS identification, IAM system or something, very similar to the argument that if you're still using MAC addresses to sort of track things and identify devices and figure out where they are and what they're doing, you may be a little behind the curve on that in that regard. Given what solutions are out there, it's probably the same thing with DHCP fingerprinting.
Yeah, fair enough. Thanks for tuning in and listening. We will cover more of the fundamentals of DHCPv6, like how that works. We'll cover that in the IPv6 basics series. So we'll bring that up and cover all of how the messages actually work and everything else. So, keep a watch and you can catch that when it drops. Thanks for listening.
Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or a follow-up on this topic, send us a message at packetpushers.net/FU. We'd love to hear from you and continue the conversation.
Also, on packetpushers.net, you'll find a range of deep dive technical podcasts for IT pros, including heavy networking, heavy wireless, and Day 2 cloud.
There's a whole lot more on the Packet Pusher site as well, such as tutorial videos and a networking job board to help you find or fill your next great role. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.